How do you use Feature Store for real-time machine learning use cases? Easy. Just check your phone to check what stores in your city around you are open 24/7 and serving features so you can get them real-time, anytime. So useless. Well, I checked your Databricks Feature Store video and I think it is useless for my machine learning project, by the way. Why? Well, my model is serving in real time, so I need to look up my features in real time with low latency, and also I need to keep update my features with some real time inputs. You know what I mean? Okay, you can still keep your current offline feature store for machine learning model training and batch inferencing, but then you can use online feature store for real-time inferencing. Where is online feature store in Databricks? I mean, how can I use it? So let's go into your Databricks Workspace. Okay. Let's go! Hello everyone, this is MG and welcome to another video, which is a complementary one to the topic we previously recorded about Databricks Feature Store. But this time in this video, we're gonna talk about what is Online Feature Store and how we can leverage Databricks Online Feature Store for serverless real-time inferencing in our machine learning projects. Let's check it out. Before we start, make sure you subscribe and hit the bell icon so you will get notified for the next video. Thank you. So this is my Databricks Workspace and this is the example notebook that I went through, ran the code, and I want to provide you a walkthrough about Online Feature Store that you can leverage in Databricks. This is actually, this is not something that I have developed, so the codes and examples here, they are available. I got them actually from Azure Databricks documentation, so I'll add the link of this example notebook from Azure Databricks docs to the video description. You can run this code with yourself again, go through the notebook, but let's elaborate further. First of all, what is Feature Store in Databricks and why do we need Online Feature Store and what we are looking to achieve here? So I assume that you already know the concept of Feature Store. If you don't, I will highly recommend you, before watching this video, watch the other video that I created, which is called or titled Databricks Feature Store. I'll add that video to the top right of this video screen. You can just click on it. I highly recommend, again, check that video. There's a comprehensive video about Feature Store, why do we need this, and how we can have it in Databricks. So with having that initial understanding about Feature Store, which is a place that we can have a unified place for storing our features, not just even for training, even for inferencing time. So as we know, featureization is a step needed in machine learning. We need to do some sort of transformation to come up with training, for example, data set to train a model. And when we score that model or inferencing stage, we need to still do those transformations again to have a data set ready for the model to get it as an input and then predict the final value for us. So instead of duplicating these transformations that we do in training versus inferencing stage, which there's a huge chance of transformation leakage and failure of the model, what Feature Store does, it will make it unified. So you will define that, hey, this is my transformations and these are the steps that I use for training the model, and then when I go to deployment, I can refer to the same Feature Store to grab my inputs and transformations to come up with the data needed for doing the prediction. In very, very high level, I just explained Feature Store, but check that video out. And here, again, when I talked about Feature Store, you heard the words that I use, which is training, prediction. So for training our machine learning model, we do not need necessarily streaming data. In some exceptional cases you might need, but in a nutshell, usually what we need is a batch load of data to train the model. So offline Feature Store is mostly needed for the time that you're training your model or when you're doing batch prediction, because you do not need to access to real-time data. That's a batch load of data that you do prediction, and a batch load of data that you need for training model. So usually in these scenarios you leverage offline feature store. Offline feature store in Databricks are mostly delta tables that we talked about in Databricks Feature Store video, that you can have all your feature tables defined there. You can look them up later instead of providing a silos progress for your Databricks projects, data science projects. You can create your features as a feature table in offline feature store as a delta table in Databricks. So later on, if another team, another data science project gonna do some machine learning stuff, they can check out to see if there are some features in feature tables available that they can use them as well for another project. So this is a great sort of collaboration as well, beside other benefits of Databricks Feature Store or Feature Store in general. But now when we talk about online feature store, that's mainly being used for the time that you want to do real-time inferencing. By real-time, I mean, let's say there's a streaming data coming in, or you have an endpoint, a real-time server that is listening 24/7 for anyone in the world, call that model to do the prediction. So for any specific real-time prediction that you're planning to do, you have an endpoint, you call the URL of that model with some inputs, and the prediction will be getting back quickly. But just imagine that within the time that you are doing inferencing for real time, you have to actually grab some features from your feature store to give it to the model and do the prediction. But the challenge is, because it's a real-time application, the time that it takes for you to grab the features from your feature store and then do the real-time prediction should be extremely fast. Sometimes you're talking about milliseconds. That's why for supporting real-time prediction by feature store, you need a sort of different type of a store that is that can support low latency with enough throughputs, that can be very fast, grab the features from feature store and do the real-time prediction for you. That's why the concept of online feature store comes here. So what we're going to do here in this actually example that we're going to walk through, here I'm going to train a machine learning model that is going to predict the quality of a drink based on a specific inputs like acidity, the volume, like fixed acidity, volatile acidity, citric acid, sugar, blah blah blah. So these are the features already that I have, and I want to predict that quality. Okay, so what we need to do first, of course, I want to train a model, and I want to create an online feature store that when I am doing real-time serving or real-time prediction, I can grab some of my features from that online store within a lookup capability. So I can, for example, check out the feature of a specific drink with drink ID in the online store to grab that features of that drink from online store and give it to my model that is doing real-time serving for me. So we talked about low latency, right? It's real time. Then what gonna be that storage that I can use to push my features there, publish my features there, and call it that, hey, this is my online feature store? Well, if you're using Azure Databricks, you have multiple choices, and let me tell you what are those choices. Here are the online store providers in Azure that you can use them with Databricks for your online feature store. The first one, which is the one we will use in this example, is Azure Cosmos Db. That's a great NoSQL data storage solution that is also optimal for real-time application as well. It will support a very fast read mechanism for your data. Even it has multi-region duplication, so it can provide a very high availability of reading your data, having access to your data for very time-sensitive applications, which here we are dealing with real-time predictions, so Cosmos DB should be very fast for us, even milliseconds, that I can grab my features from there and do the prediction, right? So there are three features that these online store need to have. You can publish features, definitely. You can have feature lookup. What is feature lookup? Well, let's say I'm going to predict the quality of a drink, and I want to grab the features of that drink for doing prediction from that online store, so I have to look up my features in online store. How? With, let's say, the drink ID. So that lookup mechanism is supported with Azure Cosmos DB for classic model serving and serverless inferencing. What is the difference between these two? Well, serverless real-time, as you can guess, that's a recent feature in Databricks. You don't need to care about creating the compute infrastructure for prediction. That's serverless. Databricks handle that. And based on the workload of inferencing, Databricks can scale up or scale down your compute for prediction. So you do not need to deal with anything. And this is actually a recommended way to go. But for classic one, you have to configure a cluster in Databricks with a couple of nodes with number of, for example, cores memories to say that, hey, this is the cluster that I'm going to host my model and do real-time prediction and have a model or cluster running 24/7 to do prediction, right? So Cosmos DB for lookup support both. But for MySQL and Azure SQL Server, you can see there are some differences. So we're going to choose Cosmos DB, and I told you the reason why: low latency, high throughput, pretty fast for looking up the features, and that's what we're going to use. So what we will do, I'm going to show you the raw data that this notebook example coming from Microsoft Azure Databricks Docs is providing for us. I have the raw data, and I will make two feature tables out of this raw data. Why? As an example, some of my features here are static. For example, there's a fixed acidity of the drink, a volatile acidity, and some of my features are changing real time. For example, the alcohol level, or let's say based on real time data I'm receiving, the alcohol level is getting changed. So I want to do the prediction of quality based on the given alcohol level that is changing real time, plus some statistical features that I have in my data set. So what I will do, of course, I need all this data to train my model, right? That's why you see there are two errors here that use both real-time features and static features for training a model. That I'm going to use XGBoost as an example, or scikit-learn, Spark, whatever. And when I register this trained model using MLflow, I will tell MLflow that, hey, register this model. Also, be aware that the way that I train this model is through this feature store. So then when I serve this model, my model automatically knows where it should go to grab my features, which is my Cosmos DB or online feature store. How it will look up to that features to do the prediction? Well, through wine ID. For example, this is my lookup feature, lookup capability. So it will go to that Cosmos DB with the given wine ID, figure out what are the statistical features from online feature store, which is Cosmos DB here, and it should be very fast. Add it to the real-time alcohol level that is changing, which is another feature, then give me the quality prediction. I know it might be a little bit not clear for you yet. Don't worry. When we go through the code, it will be much easier to understand. So let's start. The first thing, that's an open source data set. This is my data. You can see this is different drink quality features, and what we're going to predict is the quality, right? So what we need to do, first we need to do some specific changes. Some of these column names should be changed. We need to replace this for feature store. That's something needed. And we need to add ID for each drink here, because this is the key we're gonna grab the features from our online store based on the wine ID here, okay? And we are just creating sequential numbers 1, 2, 3, 4, 5, 6 and assign them as an ID, as an example. And here are the two functions that do these two transformations. One of them is just replacing this space, and the second one is creating sequential numbers to assign them as an ID. Sorry, this one is actually adding ID, and this one is renaming the column. And that's it. You can see that the one ID is added. This is the key, and the space between feature names is now gone and replaced by underscore. Okay, simple. Now what we're going to do, we are going to generate these static features and real-time features out of these raw data. This is the place that I'm doing this. Actually, you can see that I am keeping some of the data as my statistical features, and the alcohol level of drink and the quality is getting changed, right? This is my label. So I'm dropping these two, and the rest are static. And for real time, I'm just getting the alcohol. This is something real time getting changed, and quality is something that we're going to predict. And of course, we're going to get that from the static feature from one ID. Okay, now this is the time that I need to create a feature table and then publish it to my online feature store. So the first thing that you need to do first, you need to create a database, if not exist, give it a name, and in that Hive database in Databricks, by the way, this is a Hive database in Databricks, nothing else. Then I need to create a table for my features inside this database. I have already ran this code, that's why you see if I go to data, you'll see that my database is created, and also my feature table, which I'm going to show you how I did in the code, is also created. And this is the place that I need to create a feature store client, because I need to sort of somehow tell Databricks that I'm going to create a table in this database and push it to my feature store. So let's create a feature store client. This is the client, and then within this feature store I'm gonna say, hey, create a feature table, give it a name from actually this database. This is the name I'm choosing, and binary is gonna be the key, so I will use it to look up my features. And okay, where is your feature table? Here you go, it is. So I'm pushing my static features to create a feature table, and a description, which is optional. So I did it, all good. I have just created a feature table. I haven't published it yet, so my Cosmos DB is empty now, nothing there yet. Let's move on. So of course you need to have Azure Cosmos DB here if you want to use this for your online store, online feature store. So if you have not done it yet, it's pretty simple. Just go to Azure portal, just search Cosmos DB and create one. Very simple. But a couple of things you need to be cautious when you're doing this, when you want to use Cosmos DB for online feature store, which is here. If you want to use Cosmos DB, you have to create this with the SQL API. Check out the network connectivity to set all networks, and this is also the library you need to install in Databricks to set your Azure Cosmos DB as your online feature store in Databricks. Well, I already installed this and I'm going to show you how. It's pretty simple. Go to the cluster that you're running this code. Let me go to compute, cluster, libraries. You can see that this is the way I install it. You can click on install new, click on Maven, and then just add the coordinates. And I think this is the coordinate I added. Yes, you can grab it actually from documentation, but this is what I use so far. You can see it's installed here. So let me move back to my feature store notebook, online feature store notebook, and with having your Cosmos DB in place, which I already have it, I created mine. Actually, it's here. Let me go to the overview. You need to connect from Databricks to your Cosmos DB to publish your features as an online feature store in Cosmos DB. So of course you need to sort of have your credentials, permission to get access to Cosmos DB. So how you can do it? Well, you need some credentials and you have to store them as a secret in Databricks. And let me show you how. So with Databricks CLI, what you can do, you can create secrets and then put your password or credentials inside those secrets. How you can do it? This is the command. You can say, hey Databricks, create secrets for me within the or secret scope for me, and give it a scope name. So this one is feature store example read as an example, and this one is write. That's why we have two, because you can have two keys from Cosmos DB. One of them will allow you to use that key for just reading data from Cosmos DB. The other key is not only you can read, but also you can write back to Cosmos DB. So let's have two keys for different permission level and store them in Databricks. When you read data from feature store of Azure Cosmos DB, you can use the first one. When you want to write, for example, the predictions, whatever, back to online feature store or Cosmos DB here, if you want to update those features, you can use the second key. So how you can run this CLI code? What I did, you can just open your Cloud Shell. It's pretty simple. Then you have to install Databricks CLI. There's a pip install you can do in Cloud Shell, and then you can connect to Databricks with a token. So you can say Databricks config -- token, and then what it will ask, okay, give me your Databricks host. Databricks host is actually the URL of your workspace. You can just copy and paste the URL of your workspace on your browser and paste it here, and then it will tell you that, okay, give me the token. You know that how to get the token from Databricks, right? You can just go to the user settings and then just generate the token there. It's pretty simple. That's it. And when you put that token and press enter in the Cloud Shell, done. Now you're connected to this Databricks Workspace with CLI, and you need to run the command that I showed you. Let me go back for creating secret scope actually, which is the first one, and then run the second one. I already did them, all good. After that, the second step is putting your credentials or key that you have from Cosmos DB to these two. How you can do it, you say that, hey Databricks, I want to create a secret and put it to the scope that I created on the top. For the first one is a key that I have from Cosmos DB that will let me to read. The second one is a key that I have from Cosmos DB to let me write back to Cosmos DB. Run the first one in Cloud Shell, paste it here, and then it will ask you, okay, give me the key. How you can grab the key? Well, go to your Cosmos DB. If you go to the keys, you should be able to see that there's a primary key, secondary key for read and write or read only. And also copy the URL as well because you need it too. That's it. You grab the keys, grab the read key, run this code in Cloud Shell. That's the place I showed you. And the second one as well, and done. Now you have the keys of your Cosmos DB created as a Databricks secrets that Databricks can use them to connect to Cosmos DB. This is the time to publish the feature table we created to Online Feature Store, which is Cosmos DB here. What you need is your Cosmos DB URL, which is the place I showed you. You can just grab it from here, and then it knows how to publish the table there. So it will create a database name for you using the secrets that you provided in the Databricks, which are the keys that we copied. And when I say, hey, Feature Store, publish my table, all done. When I got back to my Cosmos DB, I was able to see my static features here in my Cosmos DB. Let me show you actually. So just very quickly showing you, I can click on Data Explorer. You can see the Online Feature Store example is created for me. There you go. Let's check out some of the items. If I click randomly on any of them, that's a NoSQL, of course, data. You can see that those statistical features are added with the given ID. Awesome. This is the time that I can train my model. Again, I can now use offline feature store, which can be a delta table, or here I can use the online feature store that I created. But the main purpose of online feature store is not really for training. It's mainly for real-time inferencing. So let's train and deploy the model first before doing inferencing, right? Because we don't have any model yet. So let's create a training set from online feature store. So when we deploy the model will know where the data and features being used for training. So it will use the same feature store for prediction. That's why we are creating a training data set with referring to the feature store, because we are tracking some lineage here, what data features we use for training. So with creating this training set, I am saying that this is my table, this is the label I'm going to predict, and this is the key. This is important, and of course exclude this in my training. That's not a feature, that's just a key for grabbing my features. And I load it in the training data frame and I display it. Well, seems great. This is the table that I'm gonna do the training, and that's it. So I creating my training dataset and label. I'm using random first classifier and model.fit, all done. This is the time that I register this model using MLflow. Use log model to not only register the model, but also tell the model that, hey MLflow, this is the training dataset that I use for creating this model. And because this training set is defined through feature store, so your model will have lineage information that, okay, I know which online feature store, which tables that you use for training a model. So when I do the prediction, I don't need to have all these inputs in your inferencing input object. Let me show you. So when this model is locked, that's the time I want to deploy this model, right? For serverless real-time model deployment, you can do through the code, but here I can show you in the UI. I go to the models. Okay, you can see that this classifier has been registered for me, just one version, and just click on use model for inferencing. It will start creating a serverless inferencing for you. I clicked on it before, that's why when I went to the model you can see that it is serving. So let me show you.
I go to the serving, you can see that there's a URL, copy that, actually we will need this, that has been generated for me with some logs. So let me go back to my notebook. Now I have deployed the model. What I'm gonna do here, I want to do model serving, but the inputs are not coming from the user. Some of the inputs are real-time. One of the features are changing real-time that the user provide when they call my model server to do the prediction, but the rest of this features for prediction, I want to grab them from my online feature store, not from the input, not from the user. That's why I'm grabbing the features from Cosmos DB and merge them with the real-time input that I'm getting from the user, which is alcohol level. Within the Vine ID, that's the key. I'm merging actually these two to do the prediction. Let me show you how actually. So where were we? Okay, now I want to do that, create a function that can does the prediction for me. You need Databricks token for doing prediction. So I removed mine after I ran this. It's of course credentials, you have to keep it safe. You need the URL of the model server. Remember I showed you when I deployed the model there was a URL I told you copy it. This is the reason. And then that's the way I'm creating a serving JSON with the given input, and we'll give it to the URL of the model to get the prediction back, and if it fails I can send back the error. Now that's the time I can use this predict function, which is using the model URL. You can see I have so many features. I showed you, I think I had 11 features that I need to give them to the model to do the prediction, right? But here I'm just using one feature. This is the real-time feature getting changed and my user is providing them, right? And that's it. But what about the rest of the features? Well, I am receiving the rest of the features from my Cosmos DB with using Vine ID as the key. So what it will do, it will go to Cosmos DB, check out the Vine ID number 25 to see what are the features, which are acidity, sugar level, all those stuff that we talked about, and it will merge it to my alcohol level. Now I have full set of features needed for doing the prediction. But you see that I'm not telling Databricks and this predict function, hey, go to Cosmos DB, this is the database name, grab this table. It knows everything. I'm just calling my model, and the model that we logged in MLflow knows which online features to what features are getting used. You just need to know the Vine ID and alcohol. That's it. This is extremely flexible and feasible for doing a prediction from online feature store, and because again we're using Cosmos DB, it's low latency. So even if you're doing prediction real time, that's okay. You can get up your features from online feature store real time as well and do the prediction. And that's it. Again, I'm gonna add the notebook, the link that I received this notebook from Databricks documentations. Check that out. This is just a very single example and sort of the concept of online features, so you can have complex scenarios there, but I wanted to highlight the value of this capability and for what specific scenarios online features still should be a consideration. That's all, and I hope you enjoyed this video.
We cannot always choose the music that life plays for us, but we can choose how to dance for it. Stay great, my friends, and we'll see you shortly.